Like many of you, I enjoy spending Christmas with my family, and I always do it. But for the previous 3 years, this was impossible, because I was on the other side of Atlantic Ocean doing my doctorate research. So instead, we would have Christmas Skype calls, and even from the US, I was always a part of the traditional family photo. And of course, we would have a chat on what's new and how everyone is doing. But during my final Christmas in the US, 3 years after I had moved there, I realized that none of my family really knows what is the thing that I do. Why did I go to the US? I organized a quick quiz, and the closest answer that I got came from my sister. And she said, "You observe asphalt." I mean, I do all this fancy stuff. I work in the lab, I go to the conferences, but all they know is I observe asphalt. So this is like watching the grass grow, right? So let me tell you, what did I really do? And hopefully they're watching this as well. Well, I think of asphalt every day. And I bet that you do it only if the road that takes you to the work looks something like this. It's cracked, patched, and full of potholes. Well, sadly, this is the situation in too many places, and all of us pay for it with our own money. Every euro that is saved on road maintenance causes 2 euros worth of damage to cars. And unfortunately, road maintenance is far from being a priority in most countries, so realistically, we cannot expect the situation to change anytime soon. The backlog for road repair is growing larger every year. Is there a solution? Well, I think there is, but I'll tell you what, if you can answer this one simple question. Which is the most recycled material in the developed world? Any guesses? Okay, I hear paper, I hear steel, metal, all of these are the traditional perception. Plastic, paper, aluminum. Well, actually, it is asphalt. Road pavements are the most recycled material in the developed world. In the US alone, 70 million tons of asphalt are recycled annually, 99% of all the available asphalt. This volume is close to the volume of Great Pyramid of Giza every year. And it's not even one Great Pyramid of Giza, it's actually 11 Great Pyramids of Giza that we produce every year. Well, some of this old asphalt is used for production of new asphalt, but a large portion is downgraded for use in lower value applications. Some is used for building the base of new roads, some is used for road shoulders, and some of the old highway may even be on the driveway to your home. Well, I don't want to say that improving your driveway is a bad use of any resources, but I think there's an even better way to recycle the material that was designed to resist the heavy traffic loads on highways. So during my doctorate research at Worcester Polytechnic Institute, I advanced a method that allows to recycle 100% of the old potholed asphalt into new and beautiful asphalt. And when I say beautiful asphalt, I mean the kind of asphalt you can take home and show to your family. Well, it kind of makes sense. Any new asphalt consists of stones, and the black stuff is bitumen. Any reclaimed asphalt consists of stones, and the black stuff is bitumen. So why not recycle all of it? After all, there are not that many materials that can be truly reused in the same high-value application. You know, you can take a plastic shopping bag to the store once more, and perhaps you can reuse a beer bottle or aluminum, but for most materials, recycling means downgrading of the value. A single PET bottle can contain many different materials, including the bottle itself, the paper label, the glue that holds it, the remainders of the drink, and so on. So often, plastic bottles are recycled into fibers. And fibers are later used for production of lower grade materials like carpet and plastic strapping and things like that. But with asphalt, we can truly reuse the old material into new one without lowering its value. And let me tell you how do I think this can be done. Well, asphalt ages in time. It becomes stiff, brittle, it starts to crack, water penetrates into road structure, and that's why you see those ugly potholes formed. This happens because due to losing the light oily fractions, bitumen loses its elasticity. And we need the elasticity to resist the deformations caused by the weather and our cars. So before we can reuse the old asphalt, we need to bring back this property. And naturally, the first thing to try and see if we can reverse the aging process by adding the lost oils back. This is actually not that far from using oils that are called anti-aging cream on your skin to reverse your aging process, to rejuvenate your skin. And that's what I was trying to do with bitumen. I was trying to rejuvenate bitumen. But since I didn't have any anti-aging cream at hand, I had to use some other oils. But choosing which ones to use was actually a very, very big challenge. We don't know that much about the chemical structure of bitumen, or rather, we know that it is so complicated that there is no way to come up with a single chemical formula for it. So I couldn't use a chemical approach. I had to rely on some other techniques. And in my lab, I was working with what scientists call a heuristic technique. Sounds pretty fancy, right? Well, actually, what it means is that I tried a bunch of different oils, crossed my fingers, and hoped that somehow it will work out. And you know what? It really did work out. I was truly able to find that some oils can restore the necessary properties of bitumen. And these oils can be produced from crude oil, but they can also be produced from biomaterials. And my favorite, they can even be produced from, well, waste cooking oil. Just think of that. We have lots of it in fast food industry, so each time when you go to eat your favorite burger, you would be helping me to get the material that I need to fix the road that takes you to that burger. It's like a zero waste cycle. And actually, you can think of bitumen as a superhero. You all know about the Spider-Man and Batman and Superman. And here, introducing for the very first time, the Incredible Bitumen. Well, his superpower is to keep our roads smooth and the ride safe. But just like any good plot, there has to be some challenge. For the main character and for bitumen, his weak spot is his diet. He has to follow a very strict diet. If he's starved for oils, he will crack in winter. But if we feed him too much of oils, well, in hot summer, there might be some problem. So he'll become soft and rotting will form in the wheel path of cars. But the good news is that I have figured out his diet. I know precisely how much of each oil to feed him so that he would save our cars from punctures for many, many years. And actually, let me tell you how did I get from being a doctorate student to, well, drawing superheroes. When I first arrived in the US, I wanted to blend in, so naturally I did whatever every good American does. I bought an iPad. And at the time, no one really knew what to do with them, including me, so I watched some movies, I browsed for some cat pictures over the internet, and basically that was it. But then a couple of years later, I was attending a German language course, and I sat in a desk next to a student who was using his digital pad for drawing some very nice images. And I thought, that's a pretty nice way to kill time. I should try it. So I went home and I bought the stylus, the digital drawing pen. But since this was the first time since primary school that I tried to draw something, I drew whatever I was taught, a piano, a room, and things like that. But at the same time, I was attending a business school course, and I noticed that some of my peers were using this nice presentation software for demonstrating their results. And at that point, it struck me, what if I would draw my research and use this software for presenting it? Surely, even my family would understand it. And you see, if I had not bought the seemingly unnecessary iPad or gone to the courses that were in no way required for me to graduate, I would have never been here on the TED stage with this presentation. And this kind of series of seemingly unrelated events is actually why 100% recycling is becoming a reality right now. Many different technologies had to be advanced before this was possible. For example, the way that I found out that oils can truly restore the elasticity of bitumen was by using simulative test methods. I was able to simulate a wheel path with a small wheel running over a sample of asphalt for 20,000 times. And I could also simulate cold weather or water damage. But these are all new tests. Even nowadays, pavement engineers rely mostly on empirical tests. That is, they know the characteristics of each material, they know the ideal proportions, and if they blend it all together at the right conditions, asphalt should come out perfect every time. But this is much like preparing a meal from a cookbook. You chop and prepare all the ingredients, you put them in a pot, and serve your guests. Well, without tasting beforehand, would you do that? Well, for a meal that you're preparing for the 100th time, perhaps this is fine, but what about a new dish? And what if you would have to serve 100,000 people and they would eat this meal for 20 years? Well, this is precisely the situation with new technologies for asphalt. We have to be very careful in what we deliver to our guests. Hundreds of thousands of road users will exploit the road for many, many years, so we really want to taste the asphalt before putting it on the road. And simulative test methods is a very good use for that. You know the saying, one picture is worth 1,000 words? Well, pavement engineers have their own version of this. One test is worth 1,000 expert opinions. Okay, now we have the mixture recipe, we have learned the cookbook. We can actually produce asphalt. But again, technological advance is very required for this to become a reality. And to explain the problem, let me tell you just a little bit about the production of traditional asphalt. Well, to produce asphalt, you have to heat the materials to a very high temperature, something like 160 degrees C. And this has to be done so that stones would dry out and our friend bitumen would become liquid. And during production, this is actually a good thing because it kind of binds all the stones together, it glues them. Well, bitumen is heated with electricity, something you do at home to heat water with electric kettle. The stones, on the other hand, are heated with a direct flame. And this is similar to heating marshmallows on a campfire. Well, now think of reclaimed asphalt. The stones and bitumen are blended, so we have to keep them together for heating as well. And we cannot use the electric kettle system because this is not a liquid anymore, right? But if we try to heat reclaimed asphalt with a direct flame, the bitumen starts to smoke. And it can even ignite. So the inventors had to come up with a new system, a new technology that would allow to safely heat the old asphalt without creating harmful emissions or causing flame. And many different inventors have tried to tackle this problem in the last 20 years or so, but often, the most ingenious things in life are quite simple. Just install a filter. Well, this is what Bob Frank did for his patented asphalt plant in New York City, and I was lucky to collaborate with him to verify if the mixtures that we designed in the lab would actually work in the field. You know, a simple switch from an asphalt that was milled in Brooklyn to an asphalt that was milled in Manhattan might have meant that I would have to start everything over. Bitumen might have had a different taste for oils. You know, I might have got stuck in the lab forever. But you know what? It really did work out. We were truly able to produce 100% recycled asphalt, and here you can see it putting in the streets of New York. It is just as black as any other mixture that you have ever seen, and when driving on it, you will never even know the difference. And actually, this was by far not the first site paved with 100% recycled asphalt in New York City. Already back in 2001, an experimental site was paved using a pilot version, a small-scale version of this asphalt plant. And we went back there to take samples, and of course, we drilled some samples in our new site as well. And we tested them again with the simulative test methods, and the experiments confirmed that if designed properly, totally recycled asphalt can be by any means equal to the one we're using every day. And based on this positive experience on aiming for zero waste recycling, the city of New York has allowed paving of such mixtures in the city streets starting this year. This is a huge breakthrough because previously there was a gap on the maximum amount of recycling. And there you go. We have created a zero waste cycle. We mill the old asphalt, bring it to the asphalt plant where I do the magic and decide on what oils will keep bitumen happy, and produce new asphalt using modern asphalt plants. As you can imagine, This is an environmentally friendly approach. We're barely using any new materials and basically creating a closed cycle of recycling. Every kilogram of reclaimed asphalt will save a kilogram of unrenewable resources. Oh, and one last thing. It is cheaper too. Stones, and especially our friend bitumen, are the two most expensive portions for production of asphalt. But if we use reclaimed asphalt, there's no need to buy these virgin materials because we're replacing it all with reclaimed asphalt. And of course, there are some additional costs for buying the oils and doing the simulative tests and preparing the reclaimed asphalt. But even with all of this included, 100% recycling, the production cost for 100% recycling will be up to 50% lower compared to a traditional zero recycled asphalt. This means we can pave more roads with the same budget and perhaps finally get back on track repaving those ugly pothole roads wherever there is enough of old asphalt. You know, I decided to specialize in asphalt back at the time when I was working at a road construction company, and I realized that some of my colleagues would suddenly disappear precisely on the days we had to pave asphalt. Someone had to go to university or to see a doctor, others had to do some urgent paperwork at the office. But I thought, I've seen this somewhere. This is what school children do on the days of tests. They suddenly have their stomach aches out of nowhere. And asphalt paving actually is a lot like a test. You really only get to do it once, and people will see and judge your work, especially if you fail at something. But I thought, well, I'm pretty smart, I'm not afraid of challenges, I can figure it out. I'll read a couple of books and I'll get all the glory because everyone enjoys a nice and smooth ride. Well, fast forward 10 years later, after studying in 3 different universities and many sleepless nights in the lab, I think my colleagues were probably right, skipping those days of asphalt paving. There's so much to learn about asphalt, but with these drawings, at least I tried to make clear the one thing that I do know. Asphalt can be recycled into asphalt to create a zero-waste cycle. So the next time when you're on a road trip with your friends and someone spills a drink in the car because of the bumpy road, ask your friends if they know which is the most recycled material in the world. Thank you.